this video, I'm going to talk about how we would solve exponential and logarithmic equations when my bases are the same. So when I'm solving a logarithmic or an exponential equation when the bases are the same, all I'm doing is the inverse of each side. So if I look at number 1, I notice that both my bases are 4, and it's 4 to the x minus 3. So to get the exponent out, to get the variable out of the exponent's location, I'm going to take the inverse of that, which is log. So what I'm going to end up doing is I'm going to end up multiplying both sides by log base 4. So I would basically distribute it, so it would be like log base 4 of 4 to the x minus 3, and log base 4 of 4 to the 2x minus 1. And remember, the one-to-one theorem tells us that when my base matches the number, so log 4 of 4, that makes 1, because that's why they're inverses of each other. So I'm left with x minus 3 equals, and then the same thing on the right side, log base 4 of 4 cancel out, so I'm left with 2x minus 1. You can also think about it where, remember, exponents create the problem. The exponent can also make a coefficient, which I did not mean to scroll that. So I could technically bring that down in front. So I could rewrite this if I just show you another way of how I could get to my answer. I erased too much. I could say x minus 3 log base 4 of 4 equals 2x minus 1 log 4 of 4. And then again, this just cancels out and makes 1. So I'm left with x minus 3 and 2x minus 1. So when I solve, I get x equals negative 2. If I come over and I look at the next problem, my bases are the same. So I'm just going to multiply both sides by log base 13.2. So I would do log base 13.2 of 13.2 to the x squared minus 4. And then I would do the same thing over here, 13.2 to the x plus 2. So these cancel out and make 1, so I'm left with x squared minus 4. These cancel out and make 1, so I'm left with x plus 2. Because I have two types of x's, I'm going to have to factor, so I'm going to make it equal 0. I'm going to subtract x, and I'm going to subtract 6. So now I'm going to factor. I have x minus 3 and x plus 2 equals 0. So x is going to equal 3 and negative 2. Okay? So if I go ahead and I scroll and I do the last two examples, now notice these problems here are logs. So the inverse of logs is taking it to an exponent. So that means I'm going to make this part right here an exponent, and I'm going to raise that as the exponent where the base is the base of the log. So since I have both my bases are the same, log base 4, I'm going to raise both of that and turn it into an exponent. So it's going to be 4 to the power of log 4 of x and 4 to the power of log 4 x squared minus 2. So again, those one-to-one formulas, theorems, tell us 4 to the log of 4 make 1, so I'm left with x. And here that makes x squared minus 2. So I'm going to have to factor, so I'm going to subtract x. And now I'm going to factor. I have x and x, negative 2 and positive 1. So x equals 2 and x equals negative 1. Now, we have to have a conversation with logs. Logs are never allowed to be negative. So x is not allowed to equal negative 1. And if you remember as to why, it's because a log function, if I were to just graph the parent function looks like this. Notice my x values are never negative. So my log has to be positive. My x value for my logs has to be positive. So when I plug them into these values, it has to be a positive outcome. Negative 1 doesn't work, so 2 is just my solution. If I go ahead and I look at number 4, because I have ln on both sides, remember ln is the natural log. The base of the natural log is e, which is approximately 2.7. So because to get rid of ln, to be able to cancel it out, I'm going to turn these into an exponent by making e the base. So it's e to the ln of x minus 3 and e to the ln of 4x minus 7. So e to the ln cancel out, that makes 1, so I'm left with x plus 3. E to the ln cancel out, so I'm left with 4x minus 7. So now I'm going to subtract 4x, x from both sides, and I'm going to add 7. So x is 10 thirds. And if I plug 10 thirds into both the left and the right side, it's going to stay positive. So this is how you solve equations when your bases are the same.